Okay, my computer is really struggling to run this, but I will need to show you that we do have multiplayer working, and this is not new in Cave. Actually, it's been there for a while. If you follow this channel, you know that I've already made like a multiplayer game once, but there was no sample or no code to showcase this, so I figured that I needed to work in this, and this is exactly what I did over here. Of course, I have 4 entities of the engine running at the same time, so my computer is not very happy. So I apologize for the maybe slow frame rate, but still it is running here. You can see that I can move each individual character and it reflects to the server and the client. And below here, the root of the engine here. Oh, it's actually running decently. It's running 60 frames per second. Anyways, we have 3 clients connected, which is like me, this dude here, and the others that are clients, right? So let me actually hide the controls here. And of course, if I close a client, let's try to close this one over here. Can pause and quit the game. After some seconds, it will be disconnected. Let's wait here. We can see someone's appear, and now it says that there is 2 clients connected and not 3. And this is a sample project that will be available for you very soon. It is not available yet, but I decided to record this video just like as a work in progress, and also to showcase. I want to be transparent and show what I'm working on and talk about this a little bit, but it will be available for you soon in the demo project. And this is also part of the next Cave release, which is not 1.1.0. The current release of the engine, let me try to type it here, is this one that you can access. Oh my god, my one is terrible. So this is the current release. And while I was working on this demo here, I realized that the server side, the server class that Cave have by default, was missing some function. It was like working, but it was missing a function. For example, how can I get all the connected peers? No. So I had to add this. So for this demo, I will also be shipping version 1.1. And of course, it will be compatible, so it will be great for you. But just so you know, this week, I will release this latest version, and this will also be very good because on Friday our game jam starts. So if you want to make like an online game for the game jam, whoa, this will be cool, and you'll be able to do it so using Cave, using this release, which is very nice. And I'm also working to improve the Linux build and some other minor stuff, so that's great also. Anyways, let's go ahead and show you real quick the code. Actually, before that, let me show you how to run this, because it's a little bit tricky, because of course I can press F5 and run, and if I click here to join the game as a client, you see that it is connecting, but it will be connecting forever because there's no server here, so I'm forever alone here. So the first one that I run needs to be the server. And once I have the server, of course, I cannot have another one as a server. It won't allow you because Windows and Linux won't allow this to happen. But then, if I have this, I can launch other games and do this. And the question is how to launch another instance of the engine. This is very good to ask. What you can do is press F3 to toggle controls. In Cave, if you press F3, it is literally right in here, or F3 to toggle controls. The engine will allow you to manipulate like the UI while the game is working. So all you have to do is go to settings and then game, test your game as a runtime, and then you can click save and run standalone player. If you click here, it will save and run the game in another window. You can see they are completely detached from each other. So this is a different window, a different instance of the game, and I can join as a client. So you can see that it's joined, and I already have another character here. I can move, walk around, and all that. So this is very good. And of course, I can do this again and have like a third window. And this is also a great moment to showcase the Cave UI. It is responsible. Like responsive actually, so this is good. And now, as you can see, I have multiple instances. I can walk. Let me see if I can jump. Oh, I can jump. No, I can't. Oh my god, interesting. I did not test the jump, so it seems to be working except the jump, except like the animation, it's broken. Anyways, you can see here that I can walk around and do stuff. and then of course I can close, go back to the engine, press F3 again to disable the controls, wait for these characters to log out, and then I can press F5 to quit the game. And when it comes to the code to do this, Cave Engine is actually very simple. Like if you explore, once it's released, it's not yet, but this week hopefully it will be released, the online game demo, you only see two scripts. One of them is the online player that basically controls the player, and the other is the online server. And there's a simple difference, like the online player, there's this top-down player template. It needs to be a template because of course I will be spawning as a player per player connected. Of course, if I have like 5 guys playing the game, it will be 5 templates, of course. And the only difference here, and then I have the online player script that moves around and all that and handles the animation. And the only different here from this script for the player controller to the others is that I am only updating the controls, and the controls here I mean like if you press W, A, S, and D and all that, if you press space to jump and shift to run, all this, I'm only updating this if the player has control, meaning that the player, like the instance is actually the main player of your computer. So I'm running the logic locally on each player's computer. So if you are this computer and if you are the player, then you run this. Otherwise, you don't do this. And the other difference is the animation, which is the update animation, needs to work regardless if I am if I have control of the player or not. So this is a very simple change here, but once this is done and set up, it's like as simple as it looks like. The script is pretty much the same. There's no networking in this online player. This is pretty much like only basically only player stuff, like regular gameplay stuff. And the network part lies on this online server. I do have an online server entity here, and it also have like game UI, which is of course this game text here below that I've added, and I also have the lobby UI, which is this blurred background with host game, join game, main menu, and quit game. And by the way, those buttons here, the only thing it does is unpause the game and say, oh, I am the host, so please initialize a host. I am the client, please initialize a client. And this is done by a simple like scene level variable. It's in behavioral. When I click, you can see I'm pretty much saying, hey, in the scene, create a server property and set it to true, meaning that I'm a server, of course, host game. And then unpause the game, disable the UI, and that's it. In my script here, the online server will do the rest. And then the online server is, of course, here, as you can see. And this script is very simple, actually. It is like 140 lines of code, less 150 lines of code, and it does everything. It handles like client and server, handles like the interpolation between the frames, sending the transforms, receiving the transforms, connecting, printing stuff to the screen as the bug and all that. So it's a very, very simple stuff. Actually, this is less code than I anticipated because of Visual Studio's dump, so I can delete all that. And this is, again, 140 lines of code pretty much, because this is not necessary. And what it does, let me quickly overview here to you. It creates the player for you, like the main player, the one that you actually control. Can see that I'm setting has control to true, and it does not have an address because it's local. And basically, it will prepare like a list of opponents, which is the other players you have. The server and the client, of course, it's known by default because you need to select in the UI wherever you want to be like a server and client. And it, of course, pauses the scene and activates the UI for you to pick if you want to be the server and client, of course. And then here in the update, if I am not initialized yet, it runs this initialization function here that pretty much like literally just shows the game UI and creates like, if this is the server, meaning that the scene has a property server equals to true or false, it will create a server, otherwise it will create a client. Very simple, there's no secret here. And this is literally what you need to do in Cave to create a server. cave.network.server. And of course, you can pass parameters here. You can see that I do have default parameters. The address here is localhost. You can set this to 0.0.0.0 to make it open to the entire network. So if you're connected in a LAN network with other computers in the same internet and connected to the same modem, you'll be able to do it. And then you have the port here. Default is 33333, and the same for the client here. It's default here. It by default tries to connect to localhost and the same port, but of course you can change this to something else. If you're creating, of course, a LAN game with different machines, you might want to add a different address here, like I don't know, this is not even a valid IP. I'm crazy. But anyway, this is you got the idea, you got the point here, and that's it. So this is literally the only thing you need to do to create. And before you ask, this is built on top of nnet, which is a great library. This is how to spell it. And in this example, the game itself can run as the server, but you may ask, what if I want to create like an authoritarian server that runs on a machine in the cloud? At the moment, Cave Engine does not support that because you cannot build Cave with no, we call this headerless, meaning that it does not have like a window and OpenGL and all that. It's not possible to do this in Cave, but it's good for you to know that if you use nnet, you can write your own server in Python, in C++, in whatever. You don't even need to include anything from Cave. If you understand the net, you need to understand the API, of course, the networking API, which is the net. You will be able to receive packages from Cave and parse them and create your own server, of course. It's not going to run on Cave, but you can do this. And I've actually done that in my pirate game. If you go back to this channel, you know that I do have an online game in Cave. It's a very simple one, just like a proof of concept, but the backend is not Cave. It's like, I don't know if it's Python or C++, I don't remember, but it runs a net. Anyways, but if you don't want this, if you want to do like game that you can locally be the server or the client, you can do it, and this is as simple as it gets. You just need to create a server and a client. And then in the update, of course, if it is a server, it does server stuff, and if it is a client, it does client stuff. And then last but not least, it does two things in the update. The first thing is it updates, it lerps all the positions and rotations, because of course when you are handling a server, you are not receiving positions of each user every single frame. You may miss some, so it's good to lerp the current position of each player to the next one instead of manually setting this. And of course, there's a lot of smart ways of doing this, but this is not the point of this sample project. So I'm literally doing the dumbest possible lerping, which is getting the current position and lerping with the next one by 0.2, and the same for the rotation. So this is it, everything I'm doing here. Now last but not least, I'm actually keeping track of all the opponents that are not updated for more than 5 seconds, because if I'm not receiving anything from you for 5 seconds, I'm considering that you shut down, you close the game and all that. So in this case, I'm removing you, I'm killing this. And of course, if it receives something back, need to add a new one, a new instance of the player, and that's it. Everything is solved, and that's good. So now that we have this out of our hands, let's figure out the update server and then the update client. Let me see which one is the simplest. Actually, they are both very simple. So the server, what it does is, well, the first thing, it goes to the text here, that is this text below here. And just for the sake of you understanding what's going on, it says, well, I'm the server and I do have this amount of people connected, clients connected. And I'm doing a minimum between the number of clients in the server and the length of the opponent, because since I'm manually deleting the opponent that does not get update for more than 5 seconds, and this cooldown time, which is 5 seconds, may differ from the cooldown that the server have by default. You may see different numbers here. So I'm trusting the one that have less stuff. So this is just like a local thing that I've added just for the sake of simplicity, like literally deleting the opponents by hand. So this is why I'm doing this. Then what I do is I parse all the incoming messages. In other words, everything that the users, the client sent to the server, I'm parsing this, and I'll go back to this in a moment. And of course, last but not least, I'm sending all the position back to all the peers. So I'm getting all the players, including myself and the opponents. If I'm the server, remember, only the server does this, not the client. The client only worries about himself. And I'm getting all the peers. So this is the new function that I said that I had to implement for Cave. And then what I do is for every single entity that I have, which is the player, of course, I'm getting the package position. This function is pretty much creating like a Cave network package that does have an ID, a command to say, hey, I'm passing the position and rotation. So this is it. And then it writes in the vector tree of the position and a float for the Euler angle y, right? And then it returns this. So very simple. Where are you? So I'm getting this position, and in this package, I'm basically sending to all the peers, except the peer that owns this object. Because of course, this guy here is the one that sent this position for this specific entity, so I don't need to send it back. I mean, you can if you want to do like some confirmation, but I'm trusting 100% the player here. Notice that this is a very simplistic approach for a server and client system. It allows hacking and all that. But again, the idea here is not to show you how to make networking safe, but to show you how to make networking. So this is a different story, right? So this is how the simplest way possible to make a networking game, and that's it. Then it's very important that in the end of every single frame, you manually call server update, because if you don't call this, it will not gonna flush the messages, and it will not gonna receive the messages, so the server will seem like it is not working. So it's important. You must call this at the end of every frame for the server to function properly. So yeah, this is important. So this is pretty much what the server does, and I'll go back in the parse packages in a moment. But let's figure out what the client does. So the very first thing is the client connected? Because if not, well, do nothing and just saying I'm connecting. So just set this text to client connecting. And of course, you can see here, in the end, I'm also calling update because for the same reason why I'm calling the server update here, it needs to be called. But anyways, if the client is connected, then I'll send client to connected. I'll put this text here in the screen so you know. And the logic here is very simple. I'm pretty much parsing all the incoming packages again. The same thing, the same way I did here for the server. The only difference here is that the client receives a list of packages that is literally just the package. It's called Cave Network Package. You can check the network stubs here. I will add documentation in this, by the way, before the release of this version. But this is the package, Cave Network Package. So the client receives only this because it makes no sense to have anything else. But the server, when you pop the packages from the server, like I did right here, it does not receive a list of packages. It receives instead a list of server packages. What is the difference? Well, it does have the package, as you expect here, but it also have the sender information, which is the server peer. And with this server peer, you can have like the address, the host and port of your client and all that. And of course, this does not make sense for the client because the sender will always be the server. The server is the only one communicating to the client. In this case, how Cave works, this is how Cave and how a net works. So this is why Cave works like that. So this is why I'm having this extra step just to make sure just to allow me to use the same function. This is not necessary, but I'm basically creating a server package here just to call the same function. That's it. Anyways, so this will parse all the incoming message. Again, we'll go back to this in a moment. But last but not least, it will send the client position to the server. So it gets the package for the player position and basically sends this to the server. One thing that is very nice in Net and also in Cave is that I can select if I want reliable or not messages. So I'm sending out the position, and since I'm doing this every single frame, it's like if the game is running at 60 frames per second, I'm sending this 60 times per second, there's a good chance that I'll fill my network buffer with data and it will completely explode and be very bad. So it's better for me to just, again, in a proper game, it will be better to be smarter over this and not send this every single frame, maybe in a lower tick or maybe only when the character moves actually. But for this example, it's fine. But the deal here is I'm sending this information over and over again, so I don't need to care if all the packages actually reach the server or vice versa. So I can set reliable to false, and this will pretty much make Cave and Net use plain old UDP connection. Net is built over a UDP, but again, it will just send the package and that's it. If the server receives it, that's it. If it doesn't, it's not a problem. Anyways, so you can see that I'm sending reliable as false, and also the server sends to the user reliable as false also. But of course, if you want to say the user have a nickname and I want to send this nickname once, I mean, as soon as the user sends a nickname or a message, then I need to be reliable because I need to make sure that the new nickname arrives. This is also true if I am making a game where you can PvP other players and then you can attack. Of course, I need each attack information to send to the server and vice versa, so it needs to be reliable. And in Cave, it's that simple. The only change here is that you need to set reliable to true. That's thanks to Net, and Cave takes advantage of this good implementation to provide you a very, very simple way to select if you want reliable messages are not reliable but very fast messages. So this is very good. Okay, now that we have this in mind, let's go to the last piece of the puzzle. Like, this is pretty much all the function, all the class, which is the parse packages that both the server and the client uses. And this is actually very simple. The packages will be a list of packages received by the network, either by the server or by the client in this specific example. So what I do is I iterate over all the packages. And in this case, as I said, this package, this function here that I wrote is expecting the server package. So it have a sender and the actual package. So this is why I'm getting like the sender here and the package. Okay, so for every message I do, what I do is pretty much I get the address and then an ID, because I realize for this specific implementation, again, you can do whatever implementation you want, but if you see here, every single message that I am sending over network, the first thing that I send is an ID, okay, to identify the user. And I'm basically hashing the IP address and sending this, because it's not good to send people's IP address over network like this to other peers. So I'm hashing this and sending. This is why I'm having an ID here. And basically, I use this ID to see if this opponent is already added to the game. And if this is not added to the game, what I do is I add it. So you can see here, I'm adding from the template the online player with no controls, because this is a networked player, so I don't want my current player to control it, because it will come from the network. I'm specifying the address here just for the sake of controlling everything. And this is the server only, by the way, because if you remember, the client will not going to have addresses, so it will always be 0. But the server will need the address to send back information and not send this redundant information. And then the last updated property, which I use to delete the player, as I said, if it does not get updated for a while. And last but not least, of course, I add the entity, the newly created entity, to the opponent's dictionary. And then of course, I proceed to interpret the information. So I get the opponent's entity, I reset the last updated to say, oh, this just got updated, don't worry about that. And then I read the command. At the moment, I only have one command here, which is the position and rotation. And based on this, I read the vector tree and the float that represents the position and the rotation. And since I am lerping the position and rotation every single frame, I'm not directly assigning them to the transform. What I'm doing instead is storing them in an entity property here. Because again, every single frame in the update, I get those properties here to do the actual lerping here. So this is why I'm doing this. Again, and that's it. This is the parse package. And this allows me to add a copy of each entity into each instance of the world. So if I create a server here, and then if I go ahead and create a client, the reason why you're seeing two entities here is because of these parse packages. Because each one is receiving the packages and adding the entity accordingly and interpreting the position. If I wanna do like attacking, what I can do is create another package type, just like get package position. I can create get package attack or something like that. And then the first thing I need to do, at least here in this example, is write a player ID. And then I can add like another command, like 1 or 2 or whatever, to represent an attack, and it will attack. Maybe I'll add this to the sample project, so you will know how to do it. But this is literally it. This is literally everything. I was able to explain like pretty much all you need to know about networking in Cave in like 26 minutes, including talking a lot about the engine itself and all this. Again, the client, very simple. It only have like this 5 methods. One of them, it's you need to update every single frame. The other 2 here is to see if the client is valid and if it is connected, because maybe the client is valid, but it's not connected, because maybe your internet connection is slow. So it's a valid client, but it is still trying to connect to the server. So this happens. This is why we have 2 different ones. One is to send message, and another is to get the received messages. Very simple. There's nothing else you can think about. And also those 3 functions, I'm realizing this should not be here because Cave Engine internally calls this. So we don't need to worry about this. I will remove this from the API. Package exception is just for exception stuff. You have the package itself, where that is where you write or read data using the write stuff and the read stuff. Very simple. Again. You have the peer, that this is only for the server. The client does not have this. The peer is like the connected client. You can send messages to a specific peer. You can get its address, or if you want, you can get the host and port separately. And the address is pretty much the host plus the port, right? The address would be something like this. Of course, not localhost, but this is the address. And then this is the host. And of course, the port will look like this. So this is how networking works. You have the server package, which is pretty much the server in the package. And last but not least, we have the server. And again, it's only 6 functions. How cool is that, right? How cool is that? And 1 is necessary. 1 sends to every single peer. How to send to an individual peer? Well, we can get all the peers. And you already know that the server peer do have a send message. So this is how to send to 1 peer in particular instead of to all of them. This is the receive messages. And this is to see if the server is valid, and also to see how many clients are connected to it. Simple like that. Literally it. This is all the API for the networking in Cave. And it will probably become even simpler. So I'm very happy, I'm very proud of this. It's worth mentioning again that this weekend we will have the world's first Cave Engine Game Jam, and I really highly recommend you to participate. And the engine is currently 20% off, and I forgot to say this at the beginning of this video, so I'll make sure to leave a comment below so you don't miss this, because it's a great discount and you can hang out with us in our Discord server and learn how to make games, and it will be very nice. I'll be very happy to have you over there. So that's it for this video, folks. I hope you enjoyed, and I hope you can very soon create amazing games, including multiplayer games, because it's very simple, as you saw here in Cave. This is a great demonstration to showcase everything that the engine is capable of doing. So that's it for this video, and I see you in the next one. Bye!